Let us look at proposition number 24 of book 7 of Euclid's Elements. The proposition says, if two numbers are relatively prime to any number, then their product is also relatively prime to the same. So here A and B are two numbers. They are relatively prime to a third number. So A is relatively prime to C, B is relatively prime to C, D is the product of A and B. But the proposition is saying that the product will also be relatively prime to C. Okay, let's see how we can prove. Okay, before we prove it, let's look at an example. Now we know 3 and 5 are both relatively prime to 4. The proposition is saying that the product of 3 and 5, that is 15, is also relatively prime to 4. So that is what we need to prove. Now we are given that A is relatively prime to C, B is relatively prime to C, and the product of A and B is D. Now we have to prove that C and D are also relatively prime. But let's use proof by contradiction by assuming that C and D are not relatively prime. They are not relatively prime. There must be a common measure. Let's say that common measure is E. So which means E measures both C and, remember, A and C are relatively prime. We are given that. Since E measures C and A and C are relatively prime, that means A and E are also relatively prime. Okay? Now let's say we have another number F that has as many units as E is in D. Remember, E measures D. How many times does it take to measure D? That many units are there in F. So which means F measures D based on units in E, or we can write it as D is equal to F times E. Now we have D is equal to F times C, we have D is equal to A times B. That means F times E is equal to A times B. Now, if we treat this as a product of means and extremes, F and E are, let's say, the extremes, A and B are the means. So, if product of extremes is equal to product of means, then these four numbers are going to be in proportion. That means E is to A is equal to B is to F. Now in our modern notation or thinking, what we can do is to understand this, because here what is happening is E is to A, and we are not saying equal to F is to B, we are saying B is to F. Why? Just rearrange it using algebra. E by A, so F will go here, so B by F. So that means E is to A is equal to B is to F. Now, what this proportionality means is that E measures B. Because A measures F, but for us, E measures B. But we have already seen that E measures C. That means E measures both B and C. I'm sure you have got the contradiction here. What is the contradiction? We are arriving at E measures B and C, but we started off with the fact that B is relatively prime to C. That means there can't be any number which measures both B and C. So, which means no number E exists that measures C and D. That means our assumption was wrong. And what was our assumption? That C and D are not relatively prime. Since this is wrong, we can say that C and D are relatively prime. Remember, D is the product of A and B. So we can say if A is relatively prime to C, B is relatively prime to C, then the product of A and B will also be relatively prime to C. That is proposition number 24 of book 7 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it. And if you think somebody else can also benefit from it, please do share. That's it for now.